this next assignment for Algebra 2. We're doing problems 15 through 18, I believe. Yes. So first we have, which point is a solution to the equation 2x minus y equals 4? Well, that's really just the slope-intercept form, but rearranged. So if we wanted to, we could put it in the form of y equals mx plus b by adding y to both sides and then subtracting 4. So you'd have 2x, y equals 2x minus 4. Y equals 2x minus 4. And that, you can see that if you add y and add y and subtract 4 and subtract 4, you'd end up with y equals 2x minus 4, which means that if we have y equals 2x minus 4, then when x is negative 4, y is 0. So we have a graph, negative 1, negative 2, negative 3, negative 4. This point is our y-intercept because that's what negative 4 is in the y equals mx plus b form. And then that also begs the question, what is the x-intercept? So if the y-intercept is the value when we substitute y for 0, when we substitute x for 0. So we wrote that wrong. When x is 0, y equals negative 4. That makes more sense. When x equals 0, y equals negative 4, then the x-intercept is when we substitute y for 0. So if I have 0 equals 2x minus 4, add 4 to both sides, you have 4 equals 2x, divide both sides by 2, and you're going to end up with 4 divided by 2 is 2, 2 equals x. So 1, 2, we have that point. So 0, 1, 2, when x equals 2, y equals 0. So then we can ask ourselves, now that we also have a table and we have a graph, and we didn't need to do any of this, but just for kicks, says, what if 0 and 4 were a solution? Well, we know this is a line, and the reason I did this, I know this is Algebra 2, and some of this content may be overly simplistic for you guys, and for some of you, not so much, but when it says which point, well, a point is just any point along the line that connects these coordinates, these ordered pairs. And so we have an ordered pair, for instance, at 0 and negative 4, and we have an ordered pair at 2 and 0. 2 and 0. And so any other point on this line is also an ordered pair. Speaking of which, what's the ordered pair for when x equals 1? Well, if we have 2 times 1, that's 2. So 2 times 1, if we substitute x for 1, 2 times 1 is 2, minus 4. 2 minus 4 is negative 2. So negative 2, so that means when x equals 1, y equals negative 2. Okay, so that's another point. X equals 1. So 1 goes first, that's the x. And then y goes next, that's negative 2. Okay, so now what about 0 and 4? Well, when x equals 0, y equals negative 4, not positive 4. So we know that's wrong. And we could also substitute that into the original equation. If you remember what I said, graphing this was completely unnecessary. So if I have 2 times 0, 2 times 0 minus 4, well, 2 times 0 is 0, and 0 minus 4 is just negative 4. Negative 4 does not equal 4, so we know that that is definitely not a solution. Definitely not. We also see it graphically, it doesn't match. And what about B, 1 and 2? So again, we can put that in here. Y, you put it in the original equation. 2 times 1 and minus 2 equal to 4. So 2 times 1 is 2. 2 minus 2 is negative 4. Again, that's 1 times 2 is 2. And then just 2 minus 2, or 2 minus 2, excuse me, is 0. 2 minus 2 is 0. But they're saying that this is equal to 4. 0 does not equal 4, so we know B is definitely not right. And if we look over here on the graph, when x equals 1, y is negative 2, not positive. So that's definitely wrong. Okay, see a little pattern where they're trying to trick us with A and B, where instead of negative 4, it's positive 4. Instead of negative 2, it's positive 2. They're very clever with that. C, negative 3 and negative 10. Okay, so let's do 2 times negative 3. 2 times negative 3 minus, and you see that's negative 10, so it's minus negative 10 is equal to 4. Well, let's see, 2 times negative 3 is negative 6. And then negative 6 minus minus 10, well, that's the same thing as plus 10. You could also think of that as negative 1 times negative 10, which is also positive 10, but plus 10. And negative 6 plus 10 is the same thing as 10 minus 6, which is 4. So that works. And if we plugged it into the y equals mx plus b form, that'd be 2 times negative 3 is negative 6. And then negative 6 minus 4 is negative 10. So that would work. So that would mean also if we wanted to graph it, 1, 2, 3, negative 1, negative 2, negative 3, and negative 4, negative 5, negative 6, negative 7, negative 8, negative 9, negative 10. So somewhere along here, I can sort of, okay, call it kind of over here. Fudge that a little bit, but point is 0, negative 1, negative 2, negative 3, negative 10. So pretty sure C is going to be right. Let's check out D though. D, we have negative 3, so we have 2 times negative 3 again. And then this time, so minus y, so just minus 10 equals 4. Well, that's negative 6. 2 times negative 3 is negative 6. Negative 6 minus 10. That's, does that equal 4? No, negative 6 minus 10. That's negative 6 minus another 10. So that's like negative 16 does not equal 4. So they tricked us. They tried to trick us, but it didn't work. So the answer would be C. Okay. So now, what about number 16, problem 16? Which point is the solution to the equation y equals x minus 2 squared? Well, again, it wants to know that when we put in a value for x, that we're going to get the y that they're putting on that ordered pair. And then x minus 2 squared isn't going to be a straight line. That's going to be a quadratic formula. It's going to be a parabola. In fact, that will be x squared minus 4x plus 4. And so it's going to look something like, going to have a U shape like that. But we don't have to worry about that. We'll just plug in the numbers. So plug in 3. So we have y equals x minus 2 squared. So if I have 3 minus 1 squared, well, what's 3 minus 1? 3 minus 1 is 2, and 2 squared is 4. 3 minus, oh, one moment. Sorry about that. It's 3 minus 2. So 3 minus 2 is 1, and 1 squared is 1. So that looks like that might work. What about B? If we have A looks promising. What about B if we have B equals 4 minus 2 squared. 4 minus 2, that is 2. And 2 squared equals 4. But we were supposed to get 0. See, last time we were supposed to get 1, and that worked. But nope, that does not work. So B is no bueno. What about C? C equals 1 minus 2 squared. So 1 minus 2 is negative 1. Negative 1 squared equals 1, not negative 1. So that doesn't work either. Okay, and then what about D? D is negative 3 minus 2 squared. Negative 3 minus 2 is negative 5. Negative 5 squared. Negative 5 times negative 5 is the same thing as 5 times 5, which is 25. We were supposed to get 1, so that does not work either. The only one that works is A. So A would be the answer. And then now we are on to problem 17. 17 asks us to identify the intersection of the line I and line M. Now, this is the intersection. Again, that is an ordered pair. So what is X over here? 1, 2, 3, 4. So that's 1, 1, and then 1, 2, 3, 3. So pretty simple. The identify the intersection, it's where X equals 1 and Y equals 3. And then which points are solutions to the inequality negative X minus 2Y is greater than 3. Select all that apply. So again, we're just substituting. We have negative on the outside times negative 1, and that's minus 2 times y, which is negative 2. This is X in the first one, and that's y. So first number in the ordered pair is always X, and the second one is always y. All right, so negative times negative 1 is positive 1. And then negative 2 times negative 2 is positive 4. So that's 1 plus 4. And this is supposed to be greater than 3. 1 plus 4 is 5. 5 is greater than 3. So that checks out. I'm going to circle that one. And it says which points are solutions to the inequality. So there may be more than one answer. B. We have negative on the outside and then 1. So negative 1 times positive 1 minus 2 times y, which is negative 2. And then that is supposed to be greater than 3. Is it though? Okay, so negative times positive 1 is just negative 1. Negative 2 times negative 2 is 4. So 1 plus negative 1 plus 4 is 3. That's tempting, but you see, we don't have greater than or equal to 3. It's just greater than. And 3 is not greater than 3. So I can't make that noise very well, but the incorrect sound you would hear on a game show is the sound you should be hearing right now. So B as in Bravo is not correct. What about C? Well, negative 2, so negative times negative 2, and then minus 2 times y, which is negative 1, greater than 3. Well, negative 1 times negative 2 is just positive 2. Negative 2 times negative 1 is, that's positive 2. That's 2 times 1 is 2. 2 plus 2 is 4. 4 is greater than 3, so that checks out. C is a winner. So far we have A and C, but not B. What about D? So X is 2, negative on the outside, 2 for X, minus 2 times y, which is -4. And that's all supposed to be greater than 3. Is it though? Negative times +2. -1 times +2 is just -2. -2 times -4 is, well, that's a negative times a negative, so that's positive. 2 times 4 is 8. So that's +8 is greater than 3. And, well, -2 plus 8 is the same thing as 8 minus 2, so that's 6. 6 greater than 3. 6 is greater than 3, so that's also a winner. So, in conclusion, A as in alpha, C as in Charlie, and D as in Delta are correct, but B as in Bravo is incorrect. I know that didn't have to be 21 minutes over with the little graphing thing. I went nuts, but thank you.